isosceles. They have to be both. They have to be right and isosceles. We learned that there's a pattern. So since we learned about this pattern, it always works, because you trust Ms. Tanton that it always works, and therefore we can use it and bypass Pythagorean theorem. We can bypass it every time. Okay? No, you don't, Johan, no. Okay, so on this one, we are given the hypotenuse. We talked about yesterday, when you're looking for a hypotenuse, you multiply by root 2. When you're looking for a hypotenuse, you multiply by root 2. When you're looking for a leg, you divide by root 2. And that's why y'all are in Geometry K, because some of these problems are not as pretty as 3 root 2. They don't all follow the beautiful pattern. We have to know how to find the missing sides even when the answer is not pretty. So I know that I'm looking for a leg. I know that I'm going backwards. So I know I'm going to have to take my hypotenuse and I'm going to have to divide it by root 2. I have to go backwards. I have to do the opposite of multiply. This is one where we have no choice. We have to rationalize the denominator. So in the numerator, we're going to have 5 root 6 because we're allowed to multiply 3 times 2. And in the denominator, we're going to have 2. This is an isosceles triangle. So once you find one leg, you have found both legs. Someone asked me if you're allowed to put 2.5 root 6. And I said, yes, you are allowed to, because 2.5 has an end. It's not a repeating decimal. It doesn't go on forever. So you're allowed to put that if you so desire. Now we're looking at number 8. Oh my goodness, we're in the same exact situation. We are given a hypotenuse and we're looking for a leg. So I'm not going to go over that again. I'm just going to dive right into it. We know we have to extract a root 2 out of it. We have to undo multiplying by root 2. We have to divide by root 2. Once again, you should get so good at rationalizing the denominator because we do it a lot. 12 times root 2 is 12 root 2. Square root 2 times square root 2 is 2. Heaven forbid we keep our answer like that because that is not simplified. You can actually divide 12 by 2 and we get 6. We know that they are both the same value because it's an isosceles triangle. So if you wanted to check your answer, you would say 6 root 2, 6 root 2, 6 root 2, root 2. Well, 6 root 2, root 2 is 6 times 2 is 12. So we checked our answer, we're good to go. Number 9 is an important problem because you have to draw your own segment. And I want to show you what segments students draw sometimes, and it really does them no good at all. Are you watching? We have to create triangles. And a lot of students create that triangle, and that's all well and good. You can try to solve for parts of that, but you know what? That diagonal, drawing that segment is not going to help us at all. In fact, I'm not sure we can even find that segment. So anyways, that would be the wrong segment to add to your picture. That would not get us anywhere. We do need to create a right triangle, but that's not the right triangle we want to create. This is the right triangle we want to create. Are you all noting what segment I added to my picture? I drew an altitude. Turn your head sideways. I drew an altitude. And I created a 45, 45, 90 triangle, which was very important. All right. From here to here is 26. From here to here is 14. I know I can take that 14, and I can drag it right over. So I know I can do 26 minus 14, and I can find the leg of this triangle right here. It's 12, 12, 12 root 2. I did too much work, but I just wanted to show you all the pieces. Okay? So x is 12. See that? X is 12 because we use 45, 45, 90 triangles to see the relationship there. 14 is another problem for which we need to draw some altitudes. We need to add some segments to our picture. We can draw an altitude here, and this is really not to scale, which kind of confuses me. Probably confuses you as well, right? Because that does not look like a right isosceles triangle, but it is. It is. Okay, so what can we do here? Let's see. We want to find P. P stands for the perimeter. We know this is 6 from here to here because we're just looking above. Now we need to work with this triangle. Unfortunately, that doesn't say 8 root 2. It just says 8. So we are going to have to take 8. We're trying to find a leg. We're going to have to divide it by root 2. So we're going to rationalize our denominator. 8 root 2 over 2. Oh my goodness, it's 4 root 2. We don't need to know that one, so I'm not going to put it. 4 root 2, 8, 6. Okay, this is so important. Is every single person watching, every student here. We're going to find the perimeter, and you're going to promise me you're only going to add integers to integers, and you're only going to add radicals to radicals, because that's all that's allowed. You wouldn't do this work every single time, but I just want to show you all that we have. We have 6 plus 8 plus 4 root 2 plus 6 plus 4 root 2 plus 8. I wouldn't expect you to write that addition sentence out every time, but we do need to make sure we are adding our like terms, right? So we're going to add 6 plus 8 plus 6 plus 8. Is that where we get the 28, right? And then are we allowed to add 4 root 2 plus 4 root 2? Are those like terms? Yes, they are. It's like 4x plus 4x. What is 4x plus 4x? Well, it's 8x. So it's 8 root 2. And that is the perimeter of the figure on number 14. We would never add the 28 to the 8. Don't do it. Don't ever do it. Don't even think about doing it. I didn't get the edge of that one, but you can imagine what it looks like right there, right? Okay, here we go. Who knows what this shape is called, by the way? Who knows what this shape is called? Yeah, it's a kite. Very good. Okay, so we know that this is 45, 45, 90 because when it's both right and isosceles, it has to be 45, 45, 90. We can use our trick, x root 2. 6, 6, 6 root 2. Okay, well if that has a tick mark and it's 6, and that has a tick mark, then it has to be 6. So this is 6, 6, 6 root 2. Ooh, I spy a Pythagorean triple. Do you spy it? Look at this triangle right here. This is called a Pythagorean triple. 6, 8, 10. Over here, 6, 8, 10. If you didn't know it was a triple, you would need to go to the side and you would need to do Pythagorean theorem. All right, let's add all of our integers. Add them up. 10 plus 10, 20. Add all of our radicals. 6 root 2 plus 6 root 2, 12 root 2. You don't combine those. It is not 32 root 2. It is 20 plus 12 root 2. Last problem of the day for the homework, at least. The area of a square is 121. Find the length of the diagonal. So the area of a square is 121. You know that, I'll call this y. You know that to find, hopefully, the area of a square, it's just side squared, or length times width, x times x. So I know that x squared is 121. I also know that the opposite of squaring something is square rooting. So I know that the sides of this square are 11. Now, the funny thing, not the funny thing, but the great thing about a square is that when you draw the diagonal, you create two 45, 45, 90 triangles. That's not a coincidence. That happens every time. Every time you draw the diagonal of a square, you split it into two isosceles triangles. So what's the diagonal? 11, 11, 11 root 2. You don't have to do any math. Well, you're doing math, but you don't have to do any